You're doing great with the chiming in. So the first one is assert never. And this is using something called the never type in TypeScript. And never is something that is basically, you're telling the TypeScript compiler that this will never, ever exist. It'll never happen. And you can reduce types to never in your code using things like conditionals. So for example, let's say you have this handle code function, and it takes an API error code, which is an enum with 3 different values. And then inside of the function, you've got a switch statement, and then a number of cases. So upon reaching each of these cases, TypeScript will actually subtract that type from the original union. So for assuming that you return or break or whatever. So in this case, for example, we do the case API error code input not supported, and then we return handle input not supported. Then we have a case for network error, and then we have a case for unknown. So in the default, TypeScript will have subtracted input not supported, network error, and unknown from the API error code enum. And at this point, as written, API error code, or excuse me, code is never, because there are no more possible values for code, which is an API error code, on this line. We've already handled them all. In each of these cases, we return. So the compiler is able to reduce the code variable to never. Then what we do is we call this function assert never, which we've defined above. It's a generic function because it takes a fallback. But the important part is its first argument, which is value, and the value is of type never. So TypeScript, being good about checking our types, is going to make sure that what we're passing as value is actually assignable to never. If, for example, we were to take out this case, then at this point, code would actually be API error code dot unknown. If we were to take out these 2 cases, then code would be API error code dot network error or API error code dot unknown. So basically, this pattern arises generally when you have a union that you need to subtract the cases down on until you have none left. And at that point, you want to, at compile time, prove that there are no more cases. So you call assert never on it. Now what will happen is, let's say this enum is actually auto-generated from server code, or somebody, or it actually lives in a different. Okay, so yeah, the cool thing about assert never is we're basically just taking advantage of TypeScript's ability to say that if you assign to never and whatever you're assigning isn't never, if it's more than never, then it'll complain. Very intelligently too. So we take out these 2 cases, it'll complain that those cases aren't handled. Let's say API error code is actually in a completely different module. It's far away from handle code for some reason. And somebody adds a new API error code. Then all of a sudden this function in a faraway module that said person modifying API error code never understood that they would need to fix. All of a sudden it complains and they see the error and they go fix it.
Why do you have the console error in assert never given that program?
Ooh, can I field this one?
Yeah.
Please, Alex.
So
also you have to talk about the history about how it wasn't always that way.
So this is a new assert never. The old assert never was a lot more optimistic. On the inside, all it did was throw an error. But what we learned was that we don't have perfect type safety between our API and our client. We mirror our API as best we can, but if someone on the back end adds a new value that can return and doesn't tell us about it, and we don't update our enum with this new error code, it will at runtime give us an unexpected value, and then say maybe a whole page crashes instead of just silently consoling out this error and doing the best it can.
You're going to want those error boundaries. You don't have to like throw out the baby with the bathwater.
We were throwing the baby out with the bathwater, yeah. So now we just send a little message that the baby is in trouble. The bathwater's not great, but we're doing the best we can.
So at that point, when we had that bug, actually, the function was, was it? I think it still had the console error. I don't remember actually.
It was just throw.
Yeah, I think it was just one line, and it threw, and it was very simple, and it just had the one argument of value. At that point, when that bug happened, I was like, this is terrible. Like, developers need to be thinking about the fallback case. We can't. It's not a perfect world out there. You're gonna get bitten. You got to plan for that. And so at that point, I added the fallback argument, and I was very adamant that it had to be mandatory. It wasn't going to be an optional argument. I wanted every single assert never to think about the fallback case. And I don't know, maybe I was too draconian about that, but that's why it's there. That's why assert never is generic, and that's why we're passing an empty array here, is because handle code returns an array of diagnostics. So in the terrible case where we get an error back and we don't know what to do with it, we'll do the same thing as the unknown error code, which is just return an empty array of diagnostics. This isn't real code. I just wrote it really quick before the presentation, so may not actually be the right thing to do, but it proves the example.
Have you shocked yourself in the silence?
I just thought I'd give everybody the opportunity to read the slide. I feel like if you immediately start talking when the slide comes up, people have to decide whether they're listening to you or they're reading the slide. And I just don't want to force people to make that decision.
I like that you use the word T instead of the letter T here.
I know, I thought that was quite clever. Yeah. I was pretty proud of myself for that. So this is another pattern that we use quite frequently, and in fact there was actually a TypeScript Meetup talk about it by Ted Driggs at one point, I think. Yeah.
Everyone take a second to go watch the YouTube video now. We'll wait.
Yeah. So RemoteData is, there's a whole talk out there, and I could give another talk that right now that wouldn't be as good as that talk, so I won't dive too deep into it. But basically the idea is that RemoteData was, I think, taken from Elm or something, and it is, be a little bit useful if we had the RemoteData interface on screen. But basically if only someone had put it there. So RemoteData is a generic type. And RemoteData of T basically says this is a type that could be T, but it could also be RemoteData.loading, or it could be, oh, this is scary.
Should I try it?
I don't know. It's a gamble for sure. It's definitely not showing any. Oh, there we go. So it could be. No, it's okay. Don't worry. It's happening.
You should keep explaining while he finds the
So it could be T, it could be not asked, it could be loading. And because it's a union, you're able to use something like assert never or something like that, where you're able to prove on any given line which cases you've handled of T. So you want to make sure that you've handled the case where it's loading. You want to make sure you've handled the case where it tried to load, but there was an error. And also the wonderful case of you actually got the data from some server. Oh, this is a mistake. Yeah, so this is really similar to ours. Remote data, I guess. So this is Elm, I think. Yeah. And this type sort of looks like the TypeScript remote data type. I'm guessing E and A are generics, where the failure case has E for error and the success case has A. I don't know what A stands for.
Amazing.
Amazing, amazing. You have your data. And then not asked and loading often are not distinguished from one another in terms of what you actually show to the user, but it can be quite useful in terms of caching and like actually loading the data. The data loading internals need to know whether or not the data has already been asked for before being, asking for it again. And there's some cool things that you can do once you have this. In this case, I decided to make a recipe description component to display this sweet interface recipe, which has name, description, and I guess photo as base64. And in this case, it just takes an ID, which is intended to be a recipe handle. It uses this magical hook that I've declared here to use the recipe, which basically means give me this recipe if you have it already. Hopefully it's cached. Otherwise, go get it from the server or whatever. Like, that's none of my business. I just want to be able to use recipe and get a remote data recipe back. Then we pass it to the remote data panel, which takes recipe as a parameter or a property. And it also takes a failure property so that we know what to display in the case where the data has attempted to be loaded and failed. And then there's a function as a child inside. And this is just destructuring. So we have the name, description, and photo as base64 properties of the recipe interface. And this remote data panel is very generic. It can handle, not just recipes, but all sorts of things, tea, etc.
I'll chime real quick.
Chime in.
A big difference here. So this is kind of like promise of recipe. It's an asynchronous thing. It may be coming from the server or the cache, or maybe you already have it. But the nice part that remote data gives us is with a promise, all you can do is wait for it to either succeed or fail. You can't tell if it's still loading. And so with remote data, you can actually tell if it's loading or not. So you can do a nice loading spinner much more easily. The promise is you have to do a little more boilerplate around that.
Yeah. Yeah, it would be pretty rough if inside of our component we had a promise that we would have to await, and it's just not, it's not going to work.
What do you do while you're waiting? How do you tell if you're waiting or not?
Yeah, this makes it really clear that recipe at any given time, I really do wish I had that remote data union, is in one of 4 different states. And we don't.
Just Google it. I love the TypeScript for
Are you saying that someone released an open source package that has this?
Yes, you too can install remote data.
They are our competitors.
Second one down.
That's not too bad. I thought it was the last one. README file's not great if you have to go to index and see it.
Yeah, the problem with this is not actually a good representation of it. Like, you're actually seeing the body of the functions like fail with and fail.
This is kind of it.
I guess that's, yeah, that's true.
This is our actual library that we use.
Yeah. So yeah, you have a remote data of recipe, for example, and then TypeScript is going to force you to handle each of the cases. Or you're going to shoot yourself in the foot and do something like, if not remote data is ready, return null, and then you've chosen not to handle the error case in the same way as the loading and not asked case. But then you have yourself to blame. And you can tell that we have done that before.
Question, back in April when you presented that, you were using your own version of remote data. Are you still using your own version, or you go back to Elm's now?
We've released the version.
We've released the version, and it's based on the Elm architecture. I think that the big difference is that a remote data of T is usable as a T. It's not like a wrapper around T, and that was partially for backwards compatibility. We had a bunch of functions that would take these objects or these types, and we didn't want to rewrite those functions to accept remote data of T instead. So any function that you can pass T to, you can pass remote data of T to.
Your version of remote data.
Right.
Okay.
Or, sorry, I had that slightly wrong. Any function that accepts remote data of T can take T. Not the other way around.
Quick question. Are there benefits to using the more Elm-based wrapper version of the data instead of just T by itself that you know of?
It's probably safer. It's less ergonomic because you have to reach into the wrapper, and the code is probably uglier.
I think the main thing that you gain is if your value happened to match the exact string that not asked is.
Yeah, that would be a disaster.
That's
That
an
would be
object
exact.
with a special property.
If your return value was this, then you would have a problem.
Yeah.
But it could be, and yeah, in that case, TypeScript would, and remote data would not be kind to you.
Never underestimate user input.
Yeah.
Yeah, I thought we changed that to be an object with a certain property, which is a little harder to imagine it conflicting. But also,
Maybe we did, and we haven't published it yet.
That's still from May of last year, that code, so.
Oh,
Yeah.
yes. What terrible open source maintainers would do something like that?
Okay. Controlled input. And I'll give everybody a small amount of time to read the slide. So controlled input is something that, Alex, do you know where it originally came from? It's a React thing, right? And this is our own take on it?
yes, it's a controlled input. All the React inputs are controlled inputs.
Okay.
I actually switched to management right as they produced controlled input, so I have no idea.
So it's pretty sweet. Yeah, I don't know how this necessarily differs from the React pattern. But what we have is we have a bunch of components in our UI, and the components have this common responsibility of they take a value and they allow the user to change that value, to input a new value. So maybe that's like a date picker that takes a date and allows the user to select a new date via a calendar or something like that. Or maybe it's a drop down that has a particular value or values selected, and the user can select other values. So in the past, we would have that state in Redux, or we would have that state in a React class component. And then we started making all of these functional components. And it got kind of dicey because the component itself would have to understand where the data was coming from, oftentimes. Like the component would have to be connected to Redux. Or the component would have to have like, a specific set of props to be able to accept whatever data was being displayed. So we made it more generic, and we just have this. I mean, there's 4 values here, but 2 of them are most important. One is value of t, and then onChange, which is a change handler of t. So the idea is that a given component can say, okay, I allow for input of strings, or let's just say a string. And I'm not going to own that state. Somebody above me is going to own that state. I don't care if it's Redux. I don't care if it's like a React container component. I don't care if it's a functional component that's using hooks with useState. It could be anything. All I care about is I take a value, I know how to render it, and also users are able to interact with me. They're able to update that value, and I will tell whoever's using me when that value changes. So typically what we do is we use this at a very low level, and then above that we'll have the state living in like hook using components. Anything to add?
It was after my time, man. Yeah, I don't know.
I can add something. So
Please do.
The nice thing with controlled, so the main difference from React's controlled input is that React's onChange takes an event instead of the type. So Reacts can only handle strings and numbers, probably only strings, right? Because like an input can only have strings. But ours can have entire big objects of any kind, and you can nest them. So you can have controlled input with a bunch of controlled inputs inside of it that call the onChange of the parent. So you can nest them and have a change handler for very complex objects. An entire form can be the controlled input.
Yeah, that's a really good point. So like we have this really complex filter UI in the ExtraHop product, where users can like search for devices, where the MAC address is this and the IP address is this, and then you get complex nested filters. So basically, the UI needs to produce this giant filter object that's arbitrarily nested with other filter objects. And luckily, with controlled input, because it's generic, we can have a component that's controlled input of root filter. And the interface between whatever holds the state and the component that deals with manipulation of that filter, presenting it to the user, allowing them to input, remove subfilters. The interface is very simple. It's just controlled input. Okay, so I feel like this actually isn't that useful the majority of the time, but when you need it, you need it. So for those that don't know or need a reminder, TypeScript uses structural types. And what that means is, if one object looks like another, or if an object looks like a type, then good enough. Whereas in other languages like Java, the difference between two objects is nominal, meaning that the name actually matters, even if they're identical in terms of structure. Structural typing is extremely useful. It's what you want when you're trying to test something. For example, you're writing a unit test and you have some resource that is very well typed. and you have production code using that resource, and then you want to write a test against it, and you're like, oh, I kind of don't want to go through the whole process of creating this resource. Like, I just want to pass something that looks like it. I want to mock it. And so structural typing comes in handy there and in other cases. But sometimes the name actually matters. So for example, oh no, this is worse than when it was going to sleep. This is like hibernation.
It just
Was
gives
it-
up on us at some point.
Was it in the middle of a presentation too?
The laptop's still awake. I kept it awake. I did what I could here.
Sometimes they have a cool down period. You can't turn them on for a certain time until it gets
Yeah.
to temperature.
I think it's turning back on.
I'm going to attempt to mine opaque types. An open caret.
Does anybody know a lot about the difference between opaque and nominal and structural typing, and want to talk about it briefly at a high level? Like in terms of advantages versus disadvantages.
Go for it, you.
I can say a little bit.
Go for it.
So, TypeScript tries to strike a balance between strong type safety and ergonomics. They understand that JavaScript is a little bit of a mess in modern web development. There's a lot of mutation and strange things being passed around, and a lot of objects being passed around. And so at some point, they made this decision to go with structural typing, I think both in terms of a compiler optimization and also in terms of ergonomics. It just really unlocks, it gives you almost too much freedom and flexibility for what you can do with structural typing. I personally wish that it was nominal typing, because then you could do something like have two different numbers, but if one number is of type milliseconds and the other is of type seconds, then you wouldn't be able to pass those to a function that only accepted milliseconds. That exact example is really strong to my heart, because we have a lot of times where we use actual Unix timestamps and other times where it's the JavaScript millisecond Unix timestamp. It's very confusing. Which time is which? There's no real good way to tell those two numbers apart. There's some rules of thumbs that you can use. So if you had nominal typing, you would just be able to say, I only accept milliseconds, not seconds, even though they're both numbers.
What a great example.
Nominal checks the name of your type.
The name of the type.
Structural checks the structure, which is what it has inside.
It's actually looking at the value itself instead of just the type.
Duck type.
Yeah.
Yeah.
Structural
If it-
typing is duck typing. If it walks like a duck, it talks like a duck, it's a duck.
So that's actually a great example. And
Actually, you're surprised?
no, I am. It was actually perfect in terms of timing, because the screen came back on. And so we can look at the opaque type, which is a mapped type that we use in our code base. I searched for references to this, and I was expecting like 10, 20. There were only 3, like distinct cases of using opaque. And I actually felt pretty good about that, because I don't know, feels like it should be avoided if you can. I'll talk a little bit about why. So what this does is it does this crazy thing that actually adds a brand that is not present at runtime. And the brand property adds to the structure of the type that you're creating something that has a literal string value. So that acts as the nominal property. So TypeScript is still doing structural typing, but it is doing structural typing on objects that have been branded with like this literal value, or something like that. So the case that I have here is, let's say you have an absolute time range and a relative time range. So this is, just two time anchors.
It did fall asleep. That's on me.
I touched it pretty recently. That's odd.
Sleepy little fellow there.
Sleepy computer. So we have both of these in our UI, and we need to distinguish between the two. When I saw this code, I was like, can't you just look at the value, or why didn't we just like add a type so it would be discriminated union or something? Like, do we really have to do it this way? But we did do it that way. And an example of how that ends up working is if we have a union or the original value here, which is time range, and we have a function that takes that union as a type, and then we try and use that value as if it was one of the branded types, one of the opaque types. I use those words kind of interchangeably, by the way, opaque and branded. Then we'll get an error, and it'll say, oh no, stringify relative time range takes a relative time range, and you're passing in a time range. So you need to actually tell me that it's a relative time range. And it would do something similar if we were to pass an absolute time range instead of a relative time range. I like Alex's example a lot better because in that case, you're just dealing with a primitive. It's a number. Who knows what it is? Who knows what it represents? So being able to brand it with milliseconds or seconds seems quite useful.
I have two questions about this. First, maybe you glossed over it, but why not a discriminated union here? And is that historical or something else for you?
I don't know. Like I said, when I looked at this, I was like, really? Couldn't we have had like a type?
Yeah, it changes the type stage for everything involved. Well, yeah, I mean, it's essentially you got refactor.
Yeah.
But secondarily, what's the intent of the use? So when you find the brand, the type of brand, what's the use of void there? What's up there?
That's a good question.
How is that working?
We need to,
What is this
So-
that we're looking at?
Tyler.
So it's intersecting void, which has nothing in it, with k, which could have whatever in it. It's probably going to be a string. The intersection of nothing with anything is going to be nothing. So it's going to give you a brand that the compiler will require to be something, but you won't have to store that thing at runtime. Typically, if you had a brand, if you just had k, when you created your opaque type, you'd have to store the string. Yeah.
That makes sense, but in practice, what I have seen is people have to cast explicitly into the opaque types.
Give it an object with that value in it, right?
Yeah,
There's nothing in the brand property. The brand property is effectively,
right.
because otherwise I'd have to give it an object that refers for brand, refers for absolute, right?
Yeah, yeah.
That would be
Yeah, that's
value
true.
for that thing. And even that would be impossible.
Yeah.
Well, except time range is an object too, so it could be time range and that.
So if you had a string and you wanted to make it an opaque string, if it was just k and not k and void, you couldn't cast it without some additional work?
You wouldn't have to cast it because you'd have to provide that property.
But if you did try and cast it, what would happen?
Say, this is not property.
Yeah, it would complain.
The compiler would say there's no brand property.
Okay.
The and void means you don't have to do the brand.
Yeah.
At the same time, you can't do an option property. You could toss around something from brand and all.
Right.
The generic time range.
Okay, so that's
Yeah. So one other interesting thing about opaque and branded types in general is that I recently submitted a bug to the TypeScript GitHub where I said, I have this mapped type. It's a generic mapped type, and it's a recursive generic mapped type. And some of my types inside of the type parameter that I'm passing are getting converted to never. And I was like, that seems weird. Why is that happening? And I found out that it was because they were opaque. And so an opaque type, and in this case I think it was a string, pretty sure it was a string, was being recognized when it was first assigned as an opaque type of this certain, nominal name that I'd given it. It was like opaque object path, I think. So it was a string, but it was string that was supposed to represent an object path. And I was passing it to this map type, and it was coming back as never instead of the branded type or even string. And I talked to the TypeScript people about it, and they basically said, like, yeah, it's weird that that happens in this situation and not right away. But technically what you're doing should reduce to never. And the only reason it doesn't reduce to never immediately is because if that happened, then there wouldn't be this nominal type workaround, which still seemed a little bit weird to me. But yeah, they basically said, if you're doing this, weird things are going to happen sooner or later. And in this case, sooner or later is recursive, mapped, generic type. Yeah. I don't know. Seems like a discriminated union would be good. Oh, look.
Oh, wow.
As if on cue. If people are going to think that that's like a plant.
You set that up pretty well. That's impressive.
I certainly didn't know that discriminated unions were next until I hit the forward button.
I'm less impressed, but also more impressed at the same time.
Yeah. More impressed with the universe, less impressed with me.
That's exactly it.
So in this case, we have a type A or B. And type A or B is a union type. And it's a union type of these weird objects that have a type property. In one case it's A, in the other case it's B. In the case of A, we have prop A. And in the case of B, we have prop B. So it's weird, arbitrary, contrived case. But let's say that we have a print thing function that takes a thing which is A or B. The nice thing about this A or B union is that it's called, it's what is known as a discriminated union. And a discriminated union is a union of things that have at least one common property. And generally it's type, but it doesn't have to be. That's just what, I don't know. That's what we do most often.
And that's all I know is what we do.
Yeah. And that common property allows TypeScript to discriminate between members of the union. So anytime we see type A or B in the code, we can look at the type property, and if it's A, then we know that prop A is available. Whereas if it's B, we know that prop B is available. And if we haven't checked either, or if we haven't checked the type property yet, then we'll have to deal with A or B, which is more unmanageable. And TypeScript is really good about this. It does a great job of understanding that at this level, thing is A or B, and prop A might exist, prop B might exist, type might be A or B. But then once we get into a switch statement, which is, has sort of become, inside of small functions that basically just contain switch statements, has sort of become our pattern for dealing with discriminated unions. So we switch on thing.type. Inside of case A, thing is known by TypeScript to have prop A. If we try and access prop B in here, TypeScript will complain. And the same is true of case B. And of course, we would, in the real world, combine this with our default assert never, and then we're protected against C or D or whatever.
This is really nice for use cases like Redux actions, all have a type. Or like if you're doing messages between a web worker and the main thread, and you want to tell between different types of messages, but put them all through the same code path, you can just switch on type. Those are my 2 examples.
Okay. Has property. There is, okay. So there's a whole talk on this, so I'm not going to dive too deep into this.
Who gave that talk?
I gave that talk. I assume that it's available online. I don't know. Okay. It's in our YouTube channel. So, like and subscribe. I thought somebody was going to say. So in this case, I have a person interface. Except, and sometimes I put this person in a URL or local storage or like places that the user can muck with and who knows what they do. Maybe I get it from an API that I don't trust. So I wrote this handy dandy decode URI string, decode query string that takes a URL and it returns unknown data. So unknown is this great TypeScript type. You should use it. You should especially use it over any whenever possible. It basically makes you prove that whatever value is unknown is something more than unknown, something known that you can interact with. So for example, you could do like is type of string, and if that was true, then you would be able to deal with the unknown value as a string. So we have a function called hasProperty that takes unknown, takes a property name, and then optionally takes a type guard. And if true is returned, says that not only is data an object, but it has a property with name, and name is a string. And then we also have has optional property, which works kind of similarly, except that it's asserting that the property is optional. And then we have these composable type guards like is list of, is string. And you put all of that together and use TypeScript's just natural ability. And here, data is actually, it looks like a typed union of like name colon string, or not a type union, a type intersection. Tyler?
Which one is that?
Intersection, it's type intersection, because it has a name colon string and interest colon string array and alias optional colon string.
You've talked me into intersection.
Yeah, and then, because you think it's union. Union sounds right, but it's not.
You want to say union.
Yeah, you want to say union, but don't. So at that point, it's an intersection type. If you hover over data here, it's not person. It doesn't know that it's person yet, but it is this intersection that is acceptable as person. So we can return it from this function.
That's where structural typing is kind of nice.
Yeah, we didn't have to even say that it was a person. And then in any other case, we're just going to throw an error.
We should really open source that one.
Yeah, I'd love to see the implementation of that.
Yeah.
Yeah.
I would too.
It's super useful. The only thing is that like at some point I think that we did decide that it would make more sense if there was just a library, and there are libraries that claim to do this, although I haven't investigated them too much.
That's an open request. If anyone ever wants to give a talk on this, there are like 4 different runtime type check-in libraries. Run types, quick types. TypeScript is.
Well, I wasn't even going in that direction actually. I was thinking like, given the interface person, it would be nice if there was some way to just generate the type guard.
Some of these libraries do that.
Okay, yeah. So my original zeal for this function, even though we use it all the time, has diminished a little bit because it feels like it's not the right solution for everything in the long term. But it's still super useful.
You're saying we should really take the time to research that at some point.
I mean, you can do the same thing without even creating a function. It's just really wordy. Is type of data equal to object and
Yeah.
It's shockingly wordy though, because you have to make sure it's an object and it's not null.
right.
Each time TypeScript keeps forgetting for some reason. It's not great.
And it's like really nested.
Yeah. It's very
I guess you could throw or return on each each false check returns, but then you have a whole bunch of returns. Anyway, yeah, we should probably open source
We
this.
should open source it. It's very small. It's like a nice small little alternative to the big ones.
So, like philosophically, TypeScript wants to banish that compiler step, right? And so the idea of runtime type information is kind of foreign to TypeScript itself. But it seems like the world wants to move that way. Like, what's your instinct about how this all comes together in the end?
Well, this is in fact
I mean,
runtime
that's
type checking, right?
that is one particular specific answer. I'm wondering more broadly.
I do personally wish that TypeScript had built-in kind of auto-generation of if I define an interface, it will make a little function that I can pass arbitrary data to, and it will tell me if it matches that interface or not. It'd be really nice. People have specifically asked for it. There's an open issue, or they closed the issue, and they just said, this is against our philosophy. We want to disappear at runtime, except for enums.
But
Yeah.
that doesn't necessarily mean that they don't expect somebody else to do that.
Which
Right.
4 people have.
Yeah.
Yeah, they're just like,
So it may be part of their vision for the TypeScript ecosystem, but they don't want to take responsibility for it.
I kind of feel like the JavaScript ecosystem by itself needs to find its way in that general direction. TypeScript will kind of wrap around that.
Yeah.
The kind of evolution here is. In the meantime, we'll have a bunch of community libraries that like do exactly that kind of like construct type guards.
Yeah. It feels like there's a better solution that we can all gather around, but I don't know what it is yet.
there's IOTS, quick types, run types. TypeScript is.
All right, so does anybody have any questions? There are a few other patterns that I wanted to include, but I ran out of time. We could talk about the
Custom
linter.
eslint.
We should be quick though. I feel like
Okay.
we're running long.
We're running a little long.
I'm getting tired.
Do you want to just explain what it is real fast, and I'll call up the one that we mutated?
Yeah, that sounds good. Can you even pull up the code?
Yeah.
Would that be useful?
I can pull up their code that I.
Okay, yeah. Okay. So one question that that was asked earlier is, have we written any lint rules, and how hard is that? Something like that was the question. So my favorite lint rule that we've written is actually one that checks that it checks that functions are strongly typed if they are named. And that sounds a little bit weird, but what that ends up meaning is strongly typed in this case means all of the parameters are strongly typed or given types, and also a return type is specified. So there is at least one lint rule that already exists in the wilds that guarantees that all functions are strongly typed in the way that I just described. The problem is that that becomes extremely unergonomic in the case of like inline functions like iterators, like for each. You really want to lean on inferred types in that case. So this is sort of our compromise of, Well, we export functions from modules. We define functions local to modules, and then we use them in those modules. And we also have a bunch of inline functions, like how can we ensure that the functions that we want to be strongly typed are strongly typed, and these inline functions don't have to be.
And so, eslint does have, like Alex was saying, this kind of unwieldy rule. This is the unwieldy rules source code. You can write your own linters. I haven't looked into the eslint documentation. The eslint documentation it exists, but there's not a lot of it. It's pretty light. And so when you're writing a eslint rule, your best bet is to find a rule that approximates the functionality that you're looking for, and then alter it, versus just writing one from scratch. That sounds really hard, because there's all sorts of these different built-in helpers and identifiers. So like this is a walker, an abstraction walker. You give it a file, and it recursively goes through each node in the AST. And so this is a switch statement on AST nodes. It will look at what node it's looking at. Is it a function declaration, an accessor, an arrow function, property signature? And then if it is any of those things, it will call these smaller functions. Otherwise, it just keeps going. And then you can look at all these little functions and see what they do. So like this is checking a parameter, it is checking an argument for a function. Yeah, I just kind of crawled through this file for a while and altered it to try to figure out if things were named or exported, and it worked out eventually.
Yeah, so what's the actual, I didn't actually get to the how the rule works. Like, how does it decide which functions need to be strongly typed and which don't? What's the rule?
So it only checks arrow functions, because we try to only use arrow functions. We don't do functions because they have weird things with this and the arguments array. Arrow functions can do everything that we need. And then it looks at arrow functions, and then it tries to tell if it is just assigned to a variable, or if it's exported, if it's a default export, or if a third thing is true. And I don't remember the third thing now. And then something that it doesn't do, but would be nice, is if it was a higher order function. If it was like a currying kind of thing, where it's a function that's immediately invoked by another function, it would be nice to not have to type that second one, because you have to get a type signature of the first one. It's very wordy. Was there a question?
Yeah, I mean, so this is maybe a rephrasing of that original question that got us here. I didn't think we were going to get into the details of this, but since we are, the spirit of the question I was trying to ask was more along the lines of, like, does the community really understand how difficult, or the specific ways in which it's difficult and why it has not yet happened to write an adapter for, like, eslint goes to TSLint, sorry, around TSLint goes to eslint, and like what are the limitations between those two APIs?
And I don't know that one. I don't know what eslint rules are like. We could look at the eslint typedef rule real fast and just see.
Well, I mean, maybe that's not the...
Maybe we can do that as part of like an offline
Yeah,
after
you're
the
right,
talk
you're right. Fine.
discussion.
But yeah, that's a good question. I'm not sure why they're slowly working through it. I do know that the reason the larger community is switching to eslint is they were looking at optimizing eslint to run faster. And the sorts of optimizations they wanted to make were so kind of fundamental to how it was designed that it would have been a huge effort. And they were also very similar to the fundamentals of how eslint was already built. It was like eslint had already kind of done the optimizations that they were hoping to do. So instead of bothering to rewrite eslint from the ground up, they just switched to something that was already faster. So perhaps these fundamental optimizations also affect how the rules work in a way that makes it non-trivial to translate.
Also maybe because eslint is JavaScript versus TSLint is TypeScript. So the only way we have eslint for TypeScript is because there's a plugin. So I don't think there could be a direct, what was the word?
Translation.
Yeah, between TSLint to eslint directly. on writing a custom linter. That'd be fun. Or even go into the one that you wrote in more detail.
Yeah.
Which is now obsolete. It's in eslint.
All right. Thanks, everybody. Alex and I will be around if you guys have any other questions.
Thank you.
Yeah, it's